Grade 10 learners, here I am again, Ma'am Marian B. Millanes, and I'm ready to discuss another lesson entitled Finding the Nth Term of a Geometric Sequence and Geometric Means. I hope you've learned a lot from our previous lessons dahil sa Math Pinasimple, matuto ka. At the end of the topic, the students are expected to number 1 determines the nth term of a geometric sequence, and number 2 determines geometric means between two terms. When we say geometric sequences, these are sequences obtained by multiplying a common ratio to the preceding terms in order to obtain the succeeding terms. Let's have an activity as a recall in our previous topic. Find R in the geometric sequence and give the next three terms. Here is the sequence: 6, 18, 54, and so on. In order to get R, we need to choose any two consecutive terms from the geometric sequence and divide them from right to left. Suppose I will choose 18 and 54. So from right to left, we will divide the two terms. R equals 54 divided by 18, and that is equal to 3. So the next three terms are 54 times 3 is 162. 162 times 3 is 486. 486 times 3 is equal to 1458. Another example, 16, 8, 4, and so on. First, we need to find R by choosing any two consecutive terms from the geometric sequence. So we will choose 8 and 16. So dividing the two, 8 divided by 16. But 8 cannot be divided by 16, so therefore your answer is a fraction. Remember, all answer in fraction form should always be in lowest term. The GCF for 8 and 16 is 8, so divide both numerator and denominator by the GCF. 8 divided by 8 is 1, 16 divided by 8 is 2. So the next three terms are 4 times 1 half, that is 4 times 1 divided by 2, so that is 2. 2 times 1 half, 2 times 1 is 2 divided by 2, the answer is 1. And 1 times 1 half is 1 half. What if I am going to ask for the 10th term, 20th term, and 100th term respectively? Are you going to use the same method? Why? Using the same method, multiplying the common ratio to identify the 10th term, 20th term, and 100th term is such a waste of time. We can use the general formula a sub n equals a sub 1 times r raised to n minus 1. The general formula will be used to find the nth term of the given geometric sequence and the other missing parts of it. Case number 1. Finding the nth term of the geometric sequence. Let's have the first example. Find the 7th term of the geometric sequence with a sub 1 equals 10 and r equals negative 2. By using the general formula a sub n equals a sub 1 times r raised to n minus 1, we will now substitute your given r and a sub 1. A sub 7 is equals to 10 times negative 2 raised to 7 minus 1. 7 minus 1 is 6. As you can see, negative 2 raised to 6 means multiplying negative 2 by itself 6 times. So negative 2 times negative 2, that is positive 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Positive 16 times negative 2 is negative 32. And negative 32 times negative 2 is 64. So our a sub 7 now is 10 times 64. Therefore, a sub 7 is equal to 640. Next example, find the 5th term of the geometric sequence 80, 20, 5, and so on. Let's find R first by choosing any two consecutive terms from your sequence. Suppose I will use 5 and 20. So from right to left, 5 divided by 20, that is a fraction, and the lowest term is 1/4. We will use now a sub n equals a sub 1 times r raised to n minus 1. Substitute r and a sub 1 in your given general term. So we have a sub 5 equals 80 times 1/4 raised to 5 minus 1. 5 minus 1 is 4. 1/4 raised to 4 means you will multiply 1/4 4 times by itself. 1/4 times 1/4 times 1/4 times 1/4, and that is 1/256. Continuing our solution, we have now a sub 5 equals 80 times 1/256. 80 times 1 is 80 all over 256. The GCF of 80 and 256 is 16. Dividing both numerator and denominator by 16, we have 5/16 as your a sub 5. Let's proceed to case number 2. Finding r and a sub 1 if two terms of a geometric sequence are given. First example. The third term and seventh term of a geometric sequence are 8 and 128 respectively. Find r and a sub 1. We need to find r first. By using another formula, r equals n minus kth root of a sub n all over a sub k, wherein a sub n is the last term and a sub k is the other given term. N and k are the subscript of both terms. By substitution, we have r equals 7 minus 3 root of 128 divided by 8. 128 divided by 8 is 16. 7 minus 3 is 4. So we have r equals 4th root of 16. What number did you multiply 4 times by itself in order to get a product of 16? If we will use 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So, it is not the 4th root of 16. Let us try 2. 2 times 2, 4 times 2, 8 times 2, 16. So, therefore, the 4th root of 16 is 2. Our r here is 2. Then, find a sub 1 by using any of the two terms given. Here, I will use a sub 3. And we have a sub 3 equals a sub 1 times your r is 2 raised to 3 minus 1. A sub 3 is 8. 8 equals a sub 1. Then, 2 raised to 3 minus 1 is 2 raised to 2. And that is 2 times 2. The answer is 4. So we have 8 equals a sub 1 times 4. 4a sub 1 is equal to 8. Dividing both sides by 4, a sub 1 is equal to 2. Another example. The second term and fifth term of a geometric sequence are 400 and 16 over 5 respectively. Find r and a sub 1. Find r by using n minus kth root of a sub n all over a sub k. By substitution, we have r equals 5 minus 2 root of 16 over 5 all over 400. Let us operate 16 over 5 all over 400. Let's have 1 as the denominator of 400. Then we will cross multiply. 16 times 1 is 16. All over 5 times 400 is 2000. The answer is 16 all over 2000. Dividing both numerator and denominator by their GCF, and that is 16, we have 16 divided by 16 equals 1, and 2000 divided by 16 is 125. What number did you multiply thrice in order to get 1? And what number also you multiply thrice in order to get 125? The cube root of 1 is 1, and the cube root of 125 is 5. Since 5 times 5 is 25, times 5 again, that is 125. So your r is equal to 1 over 5. Now we are ready to find a sub 1 by using any of the two terms given in your problem. We will use a sub n equals a sub 1 r raised to n minus 1. I will use a sub 5. A sub 5 is equal to a sub 1 times 1 over 5 raised to 5 minus 1. A sub 5 is 16 over 5 equals a sub 1 times 1 over 5 raised to 4. 1/5 raised to 4 is 1/5 times 1/5 times 1/5 times 1/5. So that is 1 over 625. Then let us cross multiply 16 and 625. So we have 10,000 divided by 5 equals a sub 1. So our a sub 1 is equal to 2,000. Another concept to remember: one or more terms in between two terms of a geometric sequence are called as geometric means. To apply the concept, let's have this problem. Insert a geometric mean between 2 and 8. By putting a blank between 2 and 8, so we have 3 terms. First, we need to find r. By using r equals n minus kth root of a sub n all over a sub k. So r is equals to 3 minus 1 root of 8 over 2. 8 divided by 2 is 4. 3 minus 1 is 2. So we have r equals square root of 4. Remember, when the index is an even number and the number inside is a positive number, there are always two possible answers. One is positive and the other one is negative. Therefore, the square root of 4 is equal to positive or negative 2. There are also two possible answers in this problem. If we will use r equals positive 2, 2 times 2 is 4, 4 times 2 is 8. If we will use r equals negative 2, 2 times negative 2 is negative 4, negative 4 times negative 2 is positive 8. Another example, insert two geometric means between negative 3 and 375. If we will list the terms, we have negative 3, blank, blank, 375. First, we need to find r. By using r equals n minus kth root of a sub n over a sub k. By substitution, and since we have 4 terms, we have r equals 4 minus 1 root of 375 over negative 3. 375 divided by negative 3 is negative 125. So we have r equals cube root of negative 125. In this case, if the index is an odd number and the number inside is a negative number, then the final answer is also a negative number. On the other hand, if the index is an odd number and the number inside is a positive number, the final answer is also a positive number. Therefore, the cube root of negative 125 is equal to negative 5. We have only one answer. Negative 3 times negative 5 is positive 15. Positive 15 times negative 5 is negative 75. Negative 75 times negative 5 is positive 375.